And so the polar coordinates is like we have another way of locating a point in the space. Yeah, so I think this is very interesting. Just think of primitive like 200 like hundreds of years ago. How are you gonna locate a point? So from the origin, are there other ways to locate a point? Yes, there are. The first, you can have a ray emanating from the origin to this point. All right, so let's do that. We emit from the origin to the point. So and then it looks like a vector, right? Isn't it? Look like a vector that we just talked about last time. But okay, so sure. Let's take the last time we also talked about that any point in the space, any point P in the space, we can also say like this is a vector from, so a point also can be associated with a vector. So emanating from the origin, just have a cartoon and then point to the direction, like point to the this point P, right? So let me just call this vector like VP, okay? And this is our point P, okay? So what else? So if we just have a ray, it seems like it's not enough, right? Because it looks like there are different angles, right, of the ray. Like any point in 2D space, there's different angles. So exactly, that's the second thing that we need to locate a point. So of the definition theta is that, okay, so sorry, again, the magnitude will be like the length of this, right? So, and we call it r, which is a radius. Okay, so I think this is pretty fun to think of, how do you want to invent a tool? I'm sure you're smart enough, probably in the future you can invent other tools, right? So I hope this doesn't bore you, and if you're bored, you can, this is a recorded class, you can play your favorite music, like a jazz music, right? Because I want to play a jazz music, but okay, we can play this. All right, so let's talk about there are different directions of the rays, right? So the second tool that we need is the concept of theta. And how to define theta? It is defined to be the counterclockwise angle. So compared to the, I'll say like, okay, so I try not to say x-axis, but it's like x-axis, right? The positive direction of x-axis. So theta is like you don't have to remember the definition word, which is boring, or it could be boring. You just remember this graph, okay? So you have this angle, and how are you going to draw it from the horizontal line, positive direction, and then you just do this. All right, so this is theta. All right. All right, so we have a radius r. So we have a radius r. Let me draw this. This radius gave us, it's just like exactly like the radius of a circle, right? So we also call it radius r, or magnitude, and also the theta. And then yeah, you see like in any point in 2D, right? Any point in 2D, like we have the origin, and then I have a ray, and then I have an angle. So if I have the angle here, I'm still gonna draw it counterclockwise all the way here, okay? And I also just wanted to point out that what about the horizontal, like here, and then here would be, the angle would be like 2 pi, all right? Oh, sorry, pi, which is 180 degree. And you can also take loops of circles. So you don't have to remember this, just a story. You can also keep one circle, this 2 pi, second circle, you can also do this. But the thing is, we're gonna use cosine. So whatever loop you have, like cosine 6 pi is gonna equal to cosine like 2 pi. It's gonna equal to cosine 0, right? So you just have this periodical. So cosine sine is candy because it helps us to handle the periodical thing, right? so it doesn't matter. And the only thing, counterclockwise. Counterclockwise, just like the way we draw here, right? Counterclockwise. Counterclockwise with respect to, this positive direction, right? Okay, just have a picture and you'll be fine. Yeah, so this is polar coordinates, okay? Just have a higher level concept overview, and then everything, I promise you, will become easy, right? Because the essence is every other definition problem set is centered around the key concepts of these polar coordinates, right? So if you get a hand of this, and then everything, this is like a branch of the tree, and then everything else is like centered around it. So so a good start. And then we're gonna analyze, have a high level analyze polar coordinates. So I hope this is fun to you. With respect, together with Cartesian, which is x and y. Okay. So yeah, x and y coordinates, right? Okay. So I'm just gonna draw the polar coordinates together with the x and y coordinates, and we put. So this is our polar coordinate. This is a drawing or graph of polar coordinates, right? And then I'm just gonna draw them together. So draw the Cartesian coordinates together with the polar coordinates. Let's see their relation. So this is our x and y Cartesian coordinates that we are always using from for 10 years, right? And this is our origin. And say if we have a point here, we have a point P here, and then we can a point, and then from the origin we have a vector emitting from the origin, and all the way to this point P, right? So we can say the vector VP, vector VP is OP. Just a notation is fine. All right. So okay, I'm just gonna draw the polar coordinates in blue. And remember, polar coordinate, we have mentioned that we have another component is theta. So 1, 2 components, right? So R, so polar coordinates, so we can say P equal to some R theta, okay? Is polar coordinates, and then but it's okay. And so if I'm gonna have the shadow of P onto the x-axis, so and then here is gonna be on the x-axis, here is gonna be what is this, using sine and cosine. Here is R times cosine theta, right? And then similarly, I can have the y shadow of the point of this polar coordinates P. It'll be, because the length is R, right? The length of the vector. So this is the length of R, okay? R is the length, and then the y shadow is R times sine theta, okay? All right, so this is good, and again, so we have so from this, I think you observe that we have a right triangle, which has some nice relation. So the side length here is R, the first component of the polar coordinates, right? R theta, and then sine is R, and then we have the angle counterclockwise theta, and then from and we know this this side is R times cosine theta, R times sine theta, right? So so from just trying a picture we have, so R is equal to square root of exactly R times sine theta square, and then plus R times cosine theta, right? Okay, so let me write this in this way. That so then the square root of x of xp, the x coordinate of this point P square, and then plus the y coordinates of this point P is going to be, so this is just a process of plugging in, right? So you can also have a paper, take a paper, write it down, so that you can have I give you like 15 seconds to plug it in. Yeah, it's nothing, just to plug in what we have, right? So I trust you absolutely can do this. And if you guess correctly, this would just be R times cosine theta square, and then plus R times sine theta square, right? All right, so and then next we're just gonna take out the R, so R square, and then big bracket cosine square theta plus sine this, right? So did you write it down? It's natural, right? And then from, I guess maybe you already observed that from your knowledge, and then observe that here is just 1, right? Here is just 1. Cosine for any theta, cosine square theta plus sine square theta is equal to 1. All right, so this is good. And then this just becomes square root of R, square root of R square is equal to R. All right, so this is nice. Yeah, this is nice. It's a relation between so this is a relation between Cartesian coordinates and polar coordinates, right? Yeah, so I guess I'm just gonna circle this. Oh, all right. All right, so yeah, so this is one of the relation between yeah, I'm sure this is not hard for you, between xy coordinates and polar coordinates. Okay, it's natural, right? All right, so I think this is a higher level like definition. If you get the hang of this, if this feel natural to you, I'm sure you can derive this. And so the key thing is here, right? So the key thing is the square root of x, the point. You can just say x squared plus y squared is equal to r, right? Or the point P for point P, okay? And also r is just the length of our. So r is the magnitude, right? Like we can also write r is the length or the norm of our vector OP, okay? All right, yeah. So r is the length of the vector, okay? Okay, I'll just a notation, yeah, it's fine. All right, so I think it's good. Yeah. All right. So not bad. Yeah, like again, so if you can write if you specify okay, so if the for specific question, if you specify polar coordinates, I'm just gonna be lazy. So then you can write. So first you need to specify the coordinates, right? So it's either from the background of the question or yeah, it's usually specified from the question or you specify yourself. We can write P using polar coordinates. It would just be r theta. Okay, so yeah, so this is exactly the two components of polar coordinates. One is the ray. So just look at this picture. One is the ray r, and also like where is it ray, which direction is give us a theta. Okay, so you can write a point using polar coordinates, just r theta. All right, so r is the length. You can write it, or it's the same with the norm of the vector from emanating from the origin to P. Norm is just an operator that measures the length. Okay, so OP is just a sub index. It's just a notation. So just relax, and then this is theta, right? So and then if we specify a point P, so how to write point P, right? And then using x and y coordinates. All right, so then we write this usually xy coordinate just by the name of it. You know, math and language just by the name is x and y. Okay, yeah. So and if we can, have a transform the Cartesian coordinates with the polar coordinates, we can also write the xy coordinates as, so if like we know, if we only know is polar coordinates, for example, is like, for example, 4 pi over 3. So for example, this, okay, ex. And then if we know a polar coordinates, then we can also write out its xy Cartesian coordinates, okay? And vice versa. Also, I'm sure you can, or you already know, we have xy coordinates. We can also write its polar coordinates, right? So okay, so I find this way. What is x and y if we know r and theta? So x is just gonna be, we'll talk about it, right? So x just gonna be r times cosine theta, and y just gonna be r times sine theta. Okay, so this is a higher level summary overview. And then if you know this in mind, and then everything here will be, I think every other definition will be easy, right? Because I think if you think of every other problem, like if you have 10 problems, we have like 3-4 pages of PDF, but really it's really focused on the key concepts, right? So if you know get to know something from a higher level, I think you can lift a lot of the definition together so that you don't need to, just painfully recite everything, right? Or remember everything. Because if you're gonna recite everything, then math is just painful, right? But if you know the story, here is a higher level view. I think things just could become much easier. And here, okay, so let's see. And given a given a Cartesian system of coordinates, 2D vector may be defined as magnitude v and a counterclockwise angle and the positive direction of axis in the vector. Okay, exactly what we talked about, right? So the two components of polar coordinates here. So I'm just gonna move this a little bit so that sorry. Oh my god, why is it so? Alright, so I'm just gonna move it here, and alright, so I hope this doesn't confuse you. So I'm just gonna make it larger because this is our polar coordinate graph visual, right? Okay, so yeah, it's nothing but all right, so okay, let's keep going, and let's see, and the pair v theta determines the polar coordinates of the 2D graph. Okay, so I have a lot of sentences, a lot of the languages, but we already know, right? So from this graph we already know, so yeah, so you can write a point as this, right? So write P as this, as polar, right? So you already know. And then B, and scalar components. Yeah, so yeah, it is again, if you have any 2D vector until in the origin, taking the origin of the Cartesian system, the parallel through its tips to the coordinate axis intersect the axis at y, vx, and vx and vy. This should be vy. Yeah, this is exactly like we above, like we write it out, the polar coordinates together. So what if we write polar coordinates together with Cartesian coordinates, and then we can, if you know one of them, we can transform to another, right? So, but this paragraph doesn't say much, isn't it? The pair vs vy determines the scalar coordinates of a 2D vector. Of course, this is just our usually known xy coordinates, right? So this paragraph doesn't say much. Okay, and then the link between the polar coordinates and the scalar components, we also know, but so it'll be a easy breezy. If you read through this, the link between the polar coordinates and the scalar components to convert a vector from the polar coordinates. So I guess this finally is some useful word, convert, right? Convert a vector from the polar coordinates to scalar components using the formulas. Okay, yeah, this is exactly our graph above, right? Yeah, so this is like, we usually write r times, well, okay, you can write it your own preference. So r times cosine theta and r times sine theta exactly are visuals here, right? So if you are comfortable with this visual, and then you don't need to remember much, right? Yeah, so you don't need to recite this because you know the graph, and then you can naturally, I hope you can naturally read this. Okay, and then convert a vector from the scalar components to the polar coordinates. Yeah, and then okay, that's a good point. So if you know the xy coordinates, vx, vy, how do we write it to the polar coordinates? This is just our r theta, and r we can calculate is square root of x squared plus y squared, and theta, because we know tangent theta, we can just say theta is just arc tangent. So you don't need to I guess you don't need to recite this, right? Because you can just, if you understand this overview, and then I think that is easy to, or not hard to write it, right? So yeah, so yeah, so let me write it. So you can also write r as so if you know x and y as r, it can also be written as square root of just here, right? So it writes p vx. I'll just write x and y. So x squared plus y squared, okay? And then the theta would just be the arctangent. So whatever tangent, the tangent value, so this arctangent means like the theta, the angle that we find such that the tangent theta is equal to, the tangent equal to y over x, right? All right. Yeah, but but I don't want you to get too bothered with this. So many I think just what we talk about should be enough. Okay, so and then express each vector in polar coordinates. I guess here you have the magnitude 6 and 45, so you can write A as I believe you can write it, and then B is a little bit tricky, right? So A, I'll leave it to you. You can write it out. And what about B? You can write it out, and then we gonna compare answer. And then B is a little bit so then this angle, like we need to calculate this clockwise, this angle, right? So we know here is 90 degree minus 72 degree is going to be like 18, right? And so B is going to be, length is, so r theta, right? Polar coordinates, because in this question it explicitly asks you for the polar coordinates here, right? So so it's just gonna be r theta, and then r, we know the magnitude of radius is 4, right? And then just give it an angle is gonna be so I guess 180 degrees plus 18 degrees, and this is like 4, and then 198 degree. Okay, so this is just B. Just a clockwise angle starting from the positive direction of x, and the A will just be r theta. So what is r? The radius, and 6, right? And 645, right? Okay. And then here here is not bad, like just the usual scalar. Okay, so it says scalar coordinates. Okay, scalar coordinates. Scalar coordinates here means xy coordinates here, right? So and then we can just actually count the grids, right? So this is just gonna be 4 and -1, right? I'm sure you can write 8, and then do the conversions, right? So don't be afraid of this. I'm just gonna let you start for 30 seconds, and then we're gonna write it out. Okay, so first convert something from the polar coordinates to scalar coordinates, and then just write just draw something. All right, so just start drawing something, and then convert, right? Okay, so we have the magnitude 10, and then positive direction of x. Okay, and then counterclockwise angle here, right? This theta is 120, right? So because cosine, as you can see, cosine 120 is gonna be a negative number, right? So and then here so 10 120 degree, this is polar, and then it's going to be, so I guess I'll say the scalar coordinates just gonna be 10 times cosine 120 degree, and 10 times sine, right? Okay, I'm just gonna leave it to you. Please finish this, and this is going to be a negative cosine of 60, right? And then this is, and is sine 120 the same as sine 60? Is it? I'm just gonna let you verify it. And what is cosine 3 pi over 3 is it 1/2? Yeah, and sine pi over 3 is it square root of 3 over 2? I'm just gonna let you verify, okay? You can also visualize it. So if I'm gonna add another x and y scalar coordinates, and then the angle, like you can see the shadow on the y onto y, whether it's 120 or 60, if you have a shadow to y, it will be the same, right? So this is 60, right? Whether it's 120 or 60, and we put a shadow, just shadow it onto y-axis, it will be the same, right? It'll all point out to here, right? So 10 times cosine, 10 times sine 120 and 10 times sine 60, it'll be the same. But if you take cosine here is a negative value on the x coordinates. It'll be different if we have an angle of 60 and I have a shadow on the x coordinate, it'll be here, right? So cosine, it'll be a negative sign, right? All right, so yeah, and I'm sure you can do this. So -4, -7 here. Yeah, just try to find the r and try to find the theta, right? So r is square root of x squared plus y squared, right, of this vector, and theta is just gonna be arctangent. And remember that from visualization we have that this is very large angle, so be sure that it's larger than pi, right? So arctangent theta y over x, so 7 over 4, something like this. And then if you have a calculator, you can calculate this, right? Okay, so all right, so let's see what else. The magnitude, again, magnitude of a 2D algebraic vector, I think the same, right? Just what we talk about, it's over and over again. And we also talk about this, right?